now that we've learned what we're supposed to do, let's actually watch it in action. Let's do some problems. The first problem we're going to do is x squared is greater than or equal to 4x plus 12. So if you go back to your notes from the first video, you'll see that the first step is to go ahead and move everything to the left side of the problem with 0 on the right side. So since this is a positive 4x, moving it turns it negative because we're subtracting it from both sides. Positive 12 moves and turns negative because we're subtracting it from both sides. So we end up with x squared minus 4x minus 12 is less than or equal to 0. The next step we learned in our previous video was to find the critical values. Since this is simply a quadratic, the critical values will only be x-intercepts. There will not be any wholes or asymptotes. So all we have to do to find our x-intercepts is solve the quadratic. In this case, if we can solve it by factoring, that would be best. If not, we would use quadratic formula. So x squared breaks into x, and then factors of 12 that would subtract to get 4. 6 and 2, right? My brain's not functioning very well today. So with a negative 6 and a positive 2, if we were to FOIL this back out again, we would get our negative 4 in the middle with a negative 6x plus positive 2x. Okay, so our critical values then are positive 6 and negative 2. At this point, it's impossible to know what the solution is going to be other than it is going to involve these numbers. Okay, the next step was to set up a table with our intervals. So the intervals will be from negative infinity to the smallest critical value that we have, which happens to be a negative 2. Since we're dealing with equal to, less than or equal to, we put a square bracket instead of a parenthesis. Our next interval has to start where the last one ended and go to the next critical value. Make sure you're going in order of size, so your smallest negative numbers first to your largest positive numbers. Then our last interval, of course, starts where we left off and goes to infinity. There are the intervals. Now we're going to choose a test value for each interval. It's best if you do the smallest numbers possible so that your numbers don't become huge when you're testing it. So I would just go barely below the number that we can't use, which is a negative 2. So I'm going to go with the test value of a negative 3. This interval, the best test value is 0. The only time you can't use 0 is if 0 is actually one of your critical values. Then a good test value for this section will be 7. We will still have pretty big numbers when we do that, but it will work. Okay, now we're going to evaluate each test number. So to do that, we go back to the equation we wrote when we put 0 on the right. You don't go back to the original, you go back to this step right here. I suppose you could also go to this step. That might be easier. So we'll just say here or here. Yeah, in fact, I'm pretty sure this one will be easier. Okay, so let's go ahead and take our test value and plug it in. So negative 3 minus 6 is a negative 9, and negative 3 plus 2 is a negative 1. When we multiply negative 9 and negative 1 together, we get a positive 9. So the conclusion that we reach about that test value is that the value will be positive at that point. That will yield a positive answer, positive 9, which is not less than or equal to 0. It's greater than. So that is not going to be part of our answer. But we just keep going with our table. We will conclude that at the end. Okay, our next test value is 0. That makes this really easy because all we do is take 0 minus 6 is a negative 6, 0 plus 2 is a positive 2, so the answer is negative 12. That would have been really easy to plug in here because it's just our y-intercept, negative 12, which of course is a negative value, which makes our inequality true. Okay? Then we would plug in 7. 7 minus 6 is 1. 7 plus 2 is 9. 1 times 9 is 9, so that is a positive value. So you can see that this will make our inequality false. This will make our inequality true, and this will make our inequality false. That means that our answer is this interval right here. So now we just simply write down our solution to this inequality as -2 to 6. That is the x value that satisfies the inequality. Let's look at another one. Number 2. X to the 4th is greater than x. Again, our first step is essential because we do not have a 0 over here. And the whole reason we have to have a 0 is that this whole process hinges on the fact that positive numbers are above 0 and negative numbers are below 0. So if we don't have a 0 over here, then we're not going to get an accurate result. Okay, so we have x to the 4th minus x is greater than 0. Next step is to find our critical values. We're going to do that by factoring. This is a polynomial function. It is smooth and continuous. There's no asymptotes, no holes, just x-intercepts. We factor out first the x. Then we should notice that what we have left is a difference of cubes. So x minus 1, x squared plus 1 times x, so x, and then plus 1 squared, which is 1. So that's just following our difference of squares formula. The difference of squares formula always gives a quadratic that is prime. It is not solvable. It is not factorable. The answers would be imaginary. So we cannot use that to find critical values because critical values can only be actual real numbers on a graph. And that would give us imaginary numbers if we were to use quadratic formula, and therefore not numbers on a graph. Not solvable, not on a graph. Okay? So our only critical values would come from here and here. Critical values then would be 0 and positive 1. Okay, let's go ahead and set up a table. So our intervals will be from -infinity to 0. This time I'm just using parentheses because there's no equal sign. You start where you left off, 0 to 1, and then when you get to the last critical value, your last interval is to infinity. Okay, now we choose a number to test. -1. This is unfortunate because we have to test some sort of decimal or fraction. And then this one, we can use a 2. Okay, let's go ahead and evaluate those. I would plug them into probably this step right here would be best. Okay, so we have a -1 to the 4th power, that gives us a positive 1, minus a -1, so that's plus another 1, so that's a positive 2, which is in fact greater than 0. So that one is a true result. Plug in 1/2. 1/2 to the 4th power is positive, let's see, 2 to the 4th power is that. 2 times 2 is 4 times 2 is 8 times 2 is 16, just 16, so 1/16 minus a 1/2. This is kind of ugly. I don't really want to do this fraction stuff right now. Let's see, if we change this to a fraction, it would be 8/16. So then we would go 1 minus 8/16, so -7/16. If you can figure out that it's going to be, positive or negative without actually finding the answer, that is usually okay. So see, I could have figured out before I changed this to a common denominator that 1/2 is bigger than 1/16. So if I take 1/16 and subtract a 1/2, I'm going to get a positive or a negative answer without figuring out that it's -7/16. Anyway, so the main conclusion is that the answer is negative and therefore it is not greater than 0, so that interval is false. Then our last number to plug in would be x to the fourth, 2 to the fourth, which is 16, minus 2. So that gives us a positive 14, positive answer, which is greater than 0, so it is a true result. Okay? So our solution this time is these two intervals, because they're the ones that are true, that fit our greater than inequality. Whereas last time it was the one that fit the less than inequality. Okay, so our solution is from negative infinity to 0 and 1 to infinity.